Ever wondered why circumference of a circle is 2 pi r and the area of the same is pi r square? In this video we'll see why so. Let's start with the circumference of the circle. Considering a circle with center O and having some radius r which is length OA. Now circumference of this circle will be the green border forming the circle, that is the path starting from A and returning back to the same point A. We know that the formula of circumference or perimeter of a circle, that is C is equal to 2 pi r, where r is the radius of the circle and pi is approximately 22/7 or 3.14. So C is equal to 2 pi r, which means C is equal to 2 into 3.14 into r, that is C will be 6.28 times r approximately. Let's have a look how we are getting this. For that, we'll consider a circle having some radius r shown by the length OA. We have taken a black wire having same length as that of the radius of the circle. Let's take a blue wire having same length as that of the radius of the circle. Now let's bend this blue wire and place it on the circumference starting from point A. It goes up to point B having length r. Placing the same wire on point B, it stretches up to point C again having the same length r. Continuing from point C, the wire goes up to point D having length r. Placing the same wire on D, it stretches up to point E where DE is equal to r. Again continuing from point E up to F where EF is equal to r. Next placing the wire on F up to G where FG is equal to r. Now if you see, there is a small portion of length of the circle remaining, which is GA. The length of this part is roughly 0.28 times r, which is shown by the yellow wire. Here, the circumference or perimeter of the circle will be length of AB plus BC plus CD plus DE plus EF plus FG plus GA, which is 6 times r plus 0.28 times r. Now that will give 6.28 times r. Now rewriting 6.28 as 2 into 3.14 into r, where 3.14 is pi, right? So C is equal to 2 pi r. Now let's see how we are getting the small portion GA as 0.28 r approximately. For that, we'll measure the length of GA and compare it with the length of radius. In this case, GA is measured with the help of yellow wire, which is 1.75 centimeter, and R is black wire, which is 6.3 centimeter. On taking the ratio of GA and R, we get GA by R as 1.75 by 6.3, which is 0.2777, where 7 is recurring, so it is approximately 0.28. Therefore, GA by R is 0.28, which gives GA as 0.28 times R. So now we know why the circumference is 2 pi r. Similarly, we can prove that circumference is pi d or 3.14 times d approximately. Moving on to area of the circle, we know that the area of the circle is pi r square. Let's see why. Let's have a look at a circle shaded half black and half red. So half of its area is black and half of it is red. We know that circumference of the circle will be 2 pi r. So the length of the border from A to B of black portion will be half of 2 pi r, which is pi r. Likewise, length of the border of red portion from A to B will be pi r. Let's cut the circle into two equal parts. Each semicircle will have radius r and curved path pi r. Further slicing the red and black semicircles into small triangles from circumference to the center as shown in the figure, after which we are going to place the red and black triangles alternately touching each other. What we are getting here is a rectangle made up of red and black triangles, which are originally a part of the circle shown on the left side. This rectangle has length pi r and breadth r. The curved length of semicircle becomes the length of the rectangle and the radius becomes the breadth. So we can conclude over here that area of the rectangle is length into breadth, where length is pi r and breadth is r. That gives us pi r square. So therefore area of the circle is equal to area of rectangle, which is pi r square. So hence proved that area of the circle is pi r square. Thank you for watching, and for more such interesting videos keep following Mathalite.